Hey there folks, welcome back to the Speaker Builder channel. Today I'm going to be talking about electronic crossovers in general, and in particular we're going to be critiquing the K231. This is a three-way active electronic crossover available from Xkitz electronics out of California, made by Sublime Acoustic apparently, since that's the name on the box. So let me talk just very briefly about what an electronic crossover is first of all. So with in this case, a three-way speaker system, we have to filter out the frequencies to each of the drivers so that they're not carrying too much of the load and you don't burn them out, and they're much cleaner if you have only one driver carrying any one of the frequencies within the spectrum. So we narrow the frequency of each, subjected to each driver, through crossover systems of various kinds, either a passive down here at the speaker end, or we can do it electronically here at the front end before the amplifiers. Big advantages to doing that in terms of clarity, but the downside is you would need three stereo, in this case a three-way system, you need three stereo amplifiers, one for each of these bands of frequencies, and then feeding each of the stereo drivers. So you need 6 channels of amplification in order to do a three-way electronic crossover speaker system. So keep that in mind. It can be a more expensive way to go. If you want an inexpensive way to do that, take a look at my project called Satellite Subwoofer Speakers, and I'm using car audio stuff in that kit, in that system. And it came out pretty well, so that's an inexpensive way to go. I'm trying to go high-end because I've got some of my high-end Focal drivers, and I want to build a system that's going to really sit up at the top. And I found this electronic crossover from Xkitz, and I was really excited about it because it got me into a three-way electronic crossover for under $300. And that's what was exciting about this, because the Marchand equipment, as nice as it is, it's $1,000, $1,200, like that. So that's a much more elaborate way to go, and I wanted to keep down the cost in this project. I'm kind of trying to stay down into some kind of a reasonable price range for this project. So let me critique this now a little bit, starting with the positives, and then I'll talk about the negatives. There are some really nice things about this. I didn't mention this in my list here, but cost is one of the big advantages here. It's under $300, as I already mentioned, and that makes it a very, very affordable option for folks in a pure acoustic form. There are digital forms of electronic crossover that I'm going to be actually looking at, and I'll do a critique of that down the road here. But so this is a pure analog version of a crossover, which I've always been in favor of, and certainly the Marchand device is pure, a pure analog with no digital conversion and the digital stuff like they do with the mini DSP. Digital signal processing devices, which I am actually going to, as I mentioned, going to move into. But for me, I'm old school. I like analog stuff. So this is pure analog. But so first advantage I didn't list is the price, affordable for a three-way active electronic crossover. Second, it's a small package. You can see how big it is. It's not only 4 or 5 inches wide here, 6 inches wide, and fairly light, easy to use. Third advantage is it's well built. It's a metal case. And that's kind of nice as a plastic piece on the bottom here, but the rest of it's a metal, I think, aluminum case. Another advantage, number 4, is it's very easy to use. It has just the 3 controls. This is a baffle step compensation control, and I'm not really getting into that. I think that's overkill especially for speaker systems where the bass is going to be in a separate box completely. But in any case, we've got just 3 2-channel controls here, so it's very easy to use. You just dial them in, and you can do this by ear. I've used the real-time analyzer to try to match this up. You can do it by ear, but it takes a little bit of work. Listening, careful listening and adjusting and so forth, and you get it tuned in. That would be probably the only challenge for folks. I've tuned in the car audio systems without reusing the RTA, but in this case I was using the RTA to get me in the ballpark. I could probably do a video on the RTA and what that's all about. Other folks might have other measuring devices. You can get them on your iPhone, your portable phone apps that you can download, signal generators and sound level meters. They might be adequate for just getting you in the ballpark, not for high-end measurement of any kind, but just to get you so you know that your bands are adjusted properly. But anyway, easy to use. Number 5, it has both balanced and unbalanced inputs. Now, I'm going to spend just a minute on balanced and unbalanced. For me, this is overkill to have these 1/4-inch balanced inputs. This is the kind of stuff you see in the studio. I used a lot of balanced cable, 1/4-inch balanced cable for going from one device to another in the studio. And that's 1/4-inch stuff. But I don't see 1/4-inch stuff being used in high-end audio. Everything is RCA. So, and you would think, okay, RCA is unbalanced, right? Well, that's not entirely so. Let me talk about that just a second. So here's an RCA cable, and generally RCA, and this is a cheap one, and generally the RCA cable has a center core lead, and then it has a, I'm going to take one apart and show it, but it's got a coax external wiring that is grounded and shielded. And so the external shielding is connected to ground on either, and then the center core is, of course, connected to the center lead. But that's not a balanced line. The signal has to go down and then back, right? It's a complete circuit electronically. And so it's not balanced. And so RCA cables generally are unbalanced. But now high-end RCA cables use 2 internal leads and insulation, and the coaxial shielding around the 2 leads are only connected to one end of the RCA cable. And that end is the end you plug into the amplifier. And the amplifier then, with an input signal going this way, shields the input lines all the way through this cable to the other end. But then that shielding is not connected to the ground lead here. So it is shielded all the way through, but it's a balanced line because the plus and minus are carried by 2 lines inside the core of the cable. Now that's not the case here, of course. This is a cheap one, but in high-end ones, the AudioQuest cables I have and so forth, they're all balanced lines. So that's common practice, at least in my world, in RCA cables. They're all balanced. So to have balance and unbalance is kind of a misnomer. My lanes, and it wouldn't matter here. These are unbalanced inputs, but they accept a balanced line just as well. So there's no need for this 1/4-inch balance line. I don't see 1/4-inch used in audio hi-fi, and never have. And all my units are all RCA, and they're balanced lines anyway. So I think that's overkill in this part. That would be kind of a downside that I haven't gotten to yet, but it does have the balanced inputs. And then finally, there's an external power supply is my other advantage, I think, to this, that I think, instead of having the power supply inside here producing AC, potentially producing AC field inside the box near the electronics, you have this low voltage DC input line and your AC units way out here. And so it keeps it clean. And a lot of electronics are being done that way now. A lot of devices are all done that way with separate power supplies, so that the AC field is out away from the electronics, right? So those are the upsides to this unit. Ease of use, affordable. It was all the pluses that I bought it for. But let me now talk about the downsides. There are a number of downsides, and the most importantly to me, and again, this is somewhat of an unfair critique of this unit, to be honest, because I'm comparing this to a $1,000 Phil Marchant unit, and that's not really fair. This is under $300. So to be fair, that's really kind of not really appropriate to make that kind of comparison. But in any case, my requirement for electronic crossover was real high end, as is the case for the Marchant unit, because I've got these drivers that these are $100, $150 equivalent drivers. You can't get these anymore, these full cows, but if someone were to build an equivalent system, I would say get the Etons. There are other drivers out there that are good as well, but I would get the Etons. They're $150 and $200 for the tweeter for the 2 different ones, and the mid-range drivers to match those are 150 bucks a piece. So that's kind of the level of system we're talking about. And that's not crazy money. You can spend a lot more money than that on drivers, but that's $300, $600 just for the mid and for the Ford mid and tweeter drivers. So it's not cheap money. And these are 100 bucks a piece, and the other ones that I would really like, that I would, if I didn't have these, would be 150 bucks a piece for the SBs. So we're talking high end. We're talking pretty serious money for drivers. So it probably wasn't appropriate to try to put a $300 electronic crossover in the system, right? So that's maybe on me, that I'm trying to do this on kind of a budget, because I'm not trying to spend a lot of money on this system. But anyway, so I put this in and I compared it A/B back and forth with the Phil Marchand electronic crossover, and I'll talk about some of the differences between them in just a bit, but it didn't measure up, and that's the only problem really with it, is it, especially in the high frequency range, it didn't have the sparkle or clarity. Now, I don't want that to be a discouragement to folks. If you're not, unless you have real high-end drivers, you're probably not going to hear that difference. So it's only if you're way up at this high end, spending a lot of money, are you going to probably notice that difference. And everything else within my system is at that level as well. So it's not just I've spent the money here, but the amplifiers driving my tweeters is it's a $500 amplifier, and in that system it's $150 amplifier driving the mid-range drivers. The system I'm comparing it to has equivalent drivers to these. They're virtually identical to these two drivers, or it's a virtual twin brother, the one I have to this one, in my top of the mountain system. So. That's the first critique, and again, please don't be discouraged by that. If you're not way up at the top end, if you're down here in the low budget range, this would be a good unit for you. Controls, second critique that I would have, and some of these are valid critiques that I think the company could really look at and change. The controls do not have infinite attenuation. If you turn this down, it doesn't go all the way down to zero, to no output. You can turn all these all the way down and they still produce output. That's not the end of the world. I think that there's plenty of range in each of these. The gain range is sufficient that you can balance this out regardless of what amplifiers you're driving. The other thing to do is, if you have amplifiers, as I do, with their own internal volume controls, you can adjust the volume of the amplifiers themselves. And that sometimes is advantageous if you want a little bit softer an attack. In the analog world, the harder you hit the front end of an amplifier, the more oomph it has. And you can test that out and try it at different, drive this output up high and turn the amp down and listen to how that sounds, what that character is like. Turn this down, drive the amp all the way up, get the same gain into the front end of the amp, and see what that sounds like, and it'll be a little bit different. In the analog world, it's not purely linear. There'll be a difference, and as to how hard you hit the front end of that amp and what character it produces. So that's kind of an interesting little tweak when you're putting a system together. You can kind of tweak it a bit, as I have done, to get a certain character. If you want real hard driving stuff, you hit the front end really hard. If you want it a little softer, as I have wanted, you pull back on the gain stages of the amp itself, and you can drive it a little harder. This also will punch a little harder as you drive it harder. So that's another thing to think about. But in any case, the third critique I have is the balanced inputs, and I mentioned this already, the balanced inputs are entirely unnecessary. I would not have bothered to build it with these. It looks really cool, and it's like a nice advantage, and it's completely pointless. All my RCA, my RCA ones are all balanced. If you're going to go with balanced, you buy RCA, buy balanced lines in RCA format. They're still balanced. So that's unnecessary. You see this in the, and maybe this was what part of the intention of this was, to utilize this in a pro audio world. And now in the pro audio world, everything's 1/4 inch or XLR. And so now you're gonna adapt XLR, which is fundamentally balanced, to 1/4 inch. Now you can use this so maybe that was the thinking. I just realized that you could use this in the pro audio world as a 3-way, and it would be a good device for that, actually. For under $300, would be a nice way to go to produce a 3-way active electronic system for pro audio world, for live sound, for bands and all. But otherwise, in the pro audio world, in the audio hi-fi world, home hi-fi world, RCAs are all that's needed, and we still have balance cables and all that. And then one of the, this is a little pet peeve of mine, but they could have put a little power indicator light on the front of this thing, and they didn't do that. So when you have a little power switch on the back here and you turn it on, there's no light indicating this thing is on. That would have been a simple thing to add. I would have added that. And this is a critique. As you see, it doesn't sit flat, and it's not my table. If I turn this around, it's the same thing. So that's I don't know. I think that's a problem. They should have a little bit better quality control. Maybe that's asking too much for $300. I already mentioned this, the baffle step compensation circuit in this. I thought that was overkill, but maybe there's utility to that in some applications, and especially pro audio world perhaps, but not because I'm having a bass driver in a separate box in a separate place in the room or whatever. I didn't find there's any practical application for that. Now, and I'm going to do the last one next. There's no infrasonic filter. Now, we got to talk about that a bit. And I'm using large vented alignments for my bass, and it means I'm getting an F3, the low frequency at which it'll operate down to around 30 cycles or below. It'll be about 30 cycles for this driver, but it will drop off below that at say 1 or 2. At first or second order, say 12 dB per octave or something like that, it'll drop off. Whatever, it's second or third order, drop off below that. But you're going to have a system that will produce frequencies all the way down to 5 and 10 cycles. And the amplifier certainly can do that. Now, that's fine if you're playing CDs and other sources of music and when I did recording, I always filtered 20 cycles down. I put a hard filter on the output when I mastered the CDs. But and that's probably true throughout music range actually, but when you're playing a record, the turntable itself, the mechanism of playing a record on a turntable can produce very low frequencies. And I haven't heard those for a long time because I have technically it's called an infrasonic filter. They call it a subsonic filter, but that's not the proper term. Subsonic and supersonic are terms used by pilots and flying jets, right? Supersonic is faster than the speed of sound. Subsonic is slower than the speed of sound. The proper term here is infrasonic, below the hearing threshold, which is 20 cycles. You don't want to produce in your system anything down below 20 cycles. You want to filter those out, and especially down at the 20 cycle range where you still can perhaps hear it. Playing a record, you're going to get a lot of cone motion and a lot of that low-end information from just the act of playing a record. And so this filtering of those very, very low frequencies is necessary in my mind when playing records, especially when you have a large vented alignment or a vented alignment where the cone motion is not constricted as it is with a sealed system. Sealed system wouldn't be such an issue, but with a vented system, you're going to get a lot of cone motion playing records unless you have an infrasonic filter. And that is a filter stage that filters everything from, say, 20 cycles down at, say, fourth order or something. Then you combine that fourth order filter with the natural drop-off of your driver alignment, and you're getting a very sharp drop-off below 20 cycles. So you're not going to get that infrasonic information into the room. I could hear it when I put this system in, and I'm playing a record, and I'm getting all this rumble stuff. And it's below it's kind of below the hearing threshold, but it's audible, and it's a lot of cone motion, and you're producing acoustic FM, and there's all these other problems. So that would be something that's missing in this. Now that's probably not necessary if you're not playing records. I don't think there would be an issue playing CDs. They're filtered, and the CD player is not going to produce that infrasonic information. But the records will. So if you're going to play records, you need infrasonic filter. Now there is a workaround for that. I found these a long time ago and I never used them, but they're very, very simple. And I don't even open them. I have to open them up in the package to show you. So it's an RCA filter. You plug your RCA gain in, and then it plugs into whatever device you're going into, say the bass amp. You could put these just into the bass amp, run your bass signal in here and then out, and it will filter, I think, is it second order? It'll tell me first, second, third order. It might be third order. It's a subsonic, it's called a subsonic filter, but of course we know technically it's an infrasonic filter, but you do it passively through at the signal going into the amp. So that's a way around that. I don't know if you can still get these. This was some Japanese company. They were 15 bucks. I bought them a long time ago, thinking that I was going to have to do something like that. So that's a kind of a workaround for infrasonic filtering. I could do that with this amp. So it's not an impossible thing to not have an infrasonic filter. It's not an undoable problem. You can solve the problem with very simple passive filters at the active phase prior to the amplifier. So, and I know someday I'm going to use that, but I haven't used it yet. So, because I'm using it, because in my turntable is running through the Phil Marchand, and I have a filter in that. So let me talk about one more problem with this, and to do that I have my diagrams. So I built this quick diagram to show you how this electronic crossover works. Fundamentally, the crossover utilizes these two-way crossover modules that are 24 dB per octave. It's the Linkowitz-Riley circuit, and it's a fourth order with in-phase output. And it's really nice. They're really wonderful units. But the challenge here of doing a three-way crossover is that because these crossover networks are fundamentally two-way with a high pass and a low pass, you've got to piggy bank two of them in order to get a three-way crossover. And how you do that is you come in and you cross it over at one frequency, and you have a high pass and a low pass, and then take one of those and cross it over again and get two more bands, and now you can have your three-way. So in the case of, and I believe this is how this unit is built, it starts with the first crossover in the circuit, in the signal path, at this 100 cycle, which is the range I chose. You can choose whatever you want, but my choice was 100 cycles and 3,000 cycles were the two crossover points. So it starts off at the low crossover point, and your output from that crossover is your low pass for your bass driver, and of course it goes to an amp and then to the bass speakers. And then your high pass is now from 100 cycles up, needs to be divided again, and through another crossover, which is set at 3,000 cycles at the point. So now you have a high pass above 3,000 cycles and a low pass below 3,000 cycles. And so the tweeter amplifier is fed by this signal, which is now passed at 3,000 up. It's a high pass, 3,000 cycles up is all that it sees. Goes through the amp and now to a tweeter. And the low pass is from 3,000 cycles down, remembering that it's already been filtered from 100 cycles up. So now it has that band pass from 100 cycles to 3,000 cycles. For the mid-range driver, goes to the amp and then to the mid-range speakers, and then the low pass, of course, already, as I mentioned, from 100 cycles down, goes directly to the bass amp and then to the bass speakers. The alternative to that kind of arrangement is to use the 3,000 cycle, choose the 3,000 cycle crossover frequency first in the first module. And the advantage of that is if you follow the signal path for the tweeter, you go through one electronic crossover and then through another one, then finally to the tweeter amp and to the tweeters. And because of that additional signal path to the tweeter, I argue that perhaps is why this doesn't have the high-end clarity that it could potentially have. Perhaps not. They say they use all high-end parts, but in any case, that's how I understand how this one's designed. It goes through both crossovers to get to the tweeter output. It always has to go through both to get the mid-range because you have a band pass. It has to be filtered twice, high pass and low pass. And then the bass is just getting the one filter circuit for the bass driver. The alternative to that is to start at the high frequency crossover point. So your high pass now can go directly to your tweeter amp to your tweeter. It doesn't have to go through the other electronic crossover. It goes directly to the tweeter. Now the low pass goes through the second electronic crossover, and that one filters it again for the mid-range. As always, it has to have that band pass. It's already filtered 3,000 cycles down. Now we're going to filter it 100 cycles up. Now you have that band pass for your mid-range amp to your mid-range tweeter, and your bass is being sent through both, through 3,000 cycles down and then 100 cycles down. So now that bass is now being filtered twice. So instead of having the tweeter filtered twice, you have the bass filtered twice. There is an alternative way to design this entirely, but in any case, my critique of this unit is that I understand it's designed this way. The tweeter signal path is going through both of them, and that's perhaps why the high frequencies aren't as clean as they could be. Now, the alternative way to design a crossover is to, as is the case with the Phil Marchand system, and I believe this is probably the case with a lot of the other high-end electronic crossovers that are, again, much more expensive. You're having a signal path come into a line, and the line provides for, in this case, in the Phil Marchand device that I have, the XM44, you have 4 channels. Each of the channel has availability to accept 4 modules, and these modules are filter modules that you can that he'll provide for you that do whatever kind of filtering you want to do. So you really have ultimate flexibility here. So you take one of those signal paths, you put the high pass filter in so that you're filtering everything from 3,000 cycles down so that it high passes 3,000 up. That's my frequency range I'm choosing. Now you go directly to the tweeter amp and then to the tweeters. So it's a very clean signal path. Now the mid-range driver is going to have both a low pass and a high pass. So again, you don't have no module you have to go through twice. You simply have the 2 filters in line for the mid-range driver. 3,000 cycles down, 100 cycles up. So it's that bandpass range, that range of 300 to 3,000 is being filtered. And it goes through both of those filters into the mid-range amp, into your mid-range drivers. And the low pass simply just needs the 1 filter, 100 cycles down. In this case, we talked about the infrasonic filter. So in this case, we plug in a second module that's a high pass from 20 cycles up so that you don't get those infrasonic information when you're playing records. So one more advantage to this system is that in order to get alignment of the tweeter and mid-range driver, and this is complicated stuff, if you want more information on this, go to my video called A Driver Alignment, and I talk about this. But in that video, I did actually adjust the module I plugged into a 3rd spot in this signal path for the mid-range. It was a delay circuit with an adjustment on it. And you can delay the signal going to the mid-range driver. And if you adjust the delay, and you can get the waves to line up in the bandpass region between the tweeter and the mid-range when they both are operating at about 3,000 cycles. You get a little bit of a small band in which you get both drivers operating at the same time, and you want to get those 2 waves in sync, in phase. And so one of the ways to do that is to put a delay circuit in. You want to put the delay circuit in the mid-range, which you could do here. You don't want it additional filtering at the tweeter and interfere with high frequency reproduction. So you put it here in the mid-range where it's going to be less sonically problematic. In any case, the other advantage here is that whereas with the electronic crossovers used by the Linkwitz-Riley units, they're exclusively 24 dB per octave, which isn't bad. That's nice. But here, in this case, with this design, I can put in any filter type I want here. So I chose 48 dB per octave for the tweeter and 48 dB per octave here for this filter. So that this crossover point of 3,000 cycles is at 48 dB per octave either side. So it's very, very sharp slope. So that I minimize that bandpass so that both mid-range and tweeter are only operating together in a very, very narrow band. Anyway, so that's all I really want to kind of share about crossovers today. Please feel free to comment about your experience you might have had with this or any other electronic crossovers, and we will see you next time.